connections, three-phase transformer connections. See, depending on your three-phase transformer connections, depending on your primary winding and secondary winding connections, three-phase transformers classified into so many types. Example, first one, star-star transformer. Second one, delta-delta transformer. Third one, delta-star transformer. Fourth one, star-delta transformer. Star-delta transformer. Here, for explaining this three-phase transformer connections, you have to follow some rules made by Indian standards. As per Indian standards, note one. Primary side vectors represented with capital letters, and secondary side vectors represented with small letters. And second one, let us follow one more rule. Suffix two terminals marked with the dots. Suffix two terminals marked with the dots. And third one, after comparing, after connection is completed, we are going to compare secondary line voltage with the primary line voltage by using a clock. In that clock, 2 o'clock is reference for us. Nothing but 2 o'clock is reference for us. So if you want to compare this secondary line voltage with the primary line voltage in a clock, we'll take primary side vector as minute needle, or I can say primary side vector represents minute needle, or I can say long needle in our clock. Okay, and I can say, and one more thing, secondary side vector represents our needle. Okay, and one more thing is there, very, very important. Before that, I'll ask a simple question. Please try to answer this question. Suppose if it is the transformer primary winding, this one, it is connected to source, and here is the secondary winding, and the load is here. So please tell me, if I take supply voltage V1, and this E1 is the induced EMF primary side, E2 is the induced EMF secondary side, you please try to refer, whatever I told you, vector diagram topic, there please try to see vector diagram topic. There you'll be having some idea what is the angle between E1 and E2. E1 and E2 are in phase vectors. E1, E2 are in phase vectors. They are parallel vectors. You please try to refer vector diagram. Okay, I told you already there, vector diagram of a transformer under no load, under full load also I explained in a starting session. Please try to see that. Their angle between E1 and E2 equals how much? 0 degrees. That means what? They are in phase vectors. That means what is the meaning? Suppose if it is capital E1, it is also small. You can take secondary as a small a1. If it is capital A2, it is small a2. Capital A1, small a1. capital A2, small a2. Suppose if you take this terminal as capital A1 and this becomes a small a1. If it is a2, this becomes a2. That's the meaning. That is the meaning, right? That is the meaning. Now, so that means indirectly, observe clearly, if it is a primary vector, if it is a1 and a2, secondary vector should be small a1, small a2. Or if a primary vector terminals, suppose if it is a2, if it is a1, what about here? This is small a2 and this is small a1. This is the meaning, right? Primary voltage, secondary voltage are in phase means that is the meaning. E1 and E2 will be in phase means if it is A1 and A2, this becomes small a1, small a2. If it is A2, A1, this becomes small a2, small a1. That's the meaning. Okay. So, I mean to say that primary phase voltage, this E1 means what is phase voltage of your primary side. Primary phase voltage and secondary phase voltage will be always in phase with each other. That point I'm just writing here. Primary phase voltage and secondary phase voltage are in phase with each other, In phase with each other means what? That is primary phase voltage and secondary phase voltage are in phase with each other. That is primary phase voltage vector and secondary phase voltage vector are in parallel with each other. This statement only I just indicate like this. They are parallel means what? If it is A1, this should be small a1. If it is A2, this should be small a2. If it is capital A2, this should be small a2. If it is capital A1, this should be small a1. That's the meaning, right? First note of this. Then after that I will proceed. Okay. Next, first we will explain star-star connection. Please try to observe clearly. If you understand one connection, remaining thing will be very easy. First one I am just taking star-star connection. In star-star connection, you are having two cases are there. Case 1, case 2. Two cases will be possible. So primary is in star connection. So let me have three vectors. 1, 2, 3. Secondary also star. So let me take once again three vectors here. 1, 2, 3. I told here primary side vector represented with the capital letters. So let me write here capital A1, capital A2, capital B1, capital B2, capital C1, capital C2. A1, A2 represents capital A, B1, B2 represents capital B, C1, C2 represents capital C. Similarly, secondary side vectors, I used to represent secondary side vectors with small letters. Secondary side vector represented with small letters. Small a2, small a1, small b2, small b1, small c2, small c1. And a1, a2, nothing but small a vector, this small b vector, this small c vector. And I told you, suffix 2 terminals should be marked with dots. These are suffix 1 terminals. And these are suffix 2 terminals, A2, B2, C2, A2, B2, C2. Therefore, let me keep dots here, dot, 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 dot. Okay. Similarly, please let me draw here also. So here primary will be having primary represents a star, nothing but let me take 3 vectors here, 1, 2, 3. Here also let me take 3 vectors, 1, 2, 3. So as I told you, primary represents capital letters A1, A2, B1, B2, C1, C2, small a2, small a1, small b2, small b1, small c2, small c1. Capital A, capital B, capital C, small a, small b, small c. Now suffix 2 terminals I am just indicating with the dots, dot here, dot here, dot here, dot here, dot here, dot here. And what we are doing, just observe clearly. In first connection, what we are doing? It's a star connection, right? I'll give input to A2, B2, C2. Observe guys clearly. I'll go very slow. Please try to observe. I'll give input to A2, B2, C2. That means A1, B1, C1 should short with each other. A1, B1, C1 should start with the neutral point here. This becomes star connection. This is star connection. If you want, you can observe here. It's a star connection. Giving input to A2, B2, C2. And here also, let me take output from A2, B2, C2 by providing neutral to A1, B1, C1 like this. A1, B1, C1 like this. Is it clear? We are giving input to A2, B2, C2. These terminals can be called as now connection terminals. We are taking output from A2, B2, C2. These terminals can be taken as connection terminals. Whereas capital A1, capital B1, capital C1 are short with neutral here. Small a1, small b1, small c1 short with neutral here. Therefore, this A1, B1, C1, small a1, small b1, small c1 can be called as non-connectional terminals. Wherever you are giving input can be called as connection terminals. Where you are taking output also can be called as connection terminals. Remaining terminals can be called as non-connection terminals. Now observe clearly. So as I told you, in a clock, if you see a clock, this is 12 o'clock. This is 1. Okay. So I can say, sorry, this is 12 o'clock and this is 3. This is 6. This is what I can say 9. So 12 o'clock is reference for us. Okay. So in that point, 12 o'clock is reference for us. So I'll take here also in primary side. I'll try to see A2 will come here. Suppose if I take A2, B2, C2 terminals like this, A2, B2, C2 like this. I had taken A2, I just kept A2 at a 12 o'clock place. That means which one is reference for us? A is reference for us. It means A2 is reference for us. It means I can say A terminals are a reference for us. We have to compare small a with capital A. Okay. Then you'll get angle between the secondary line voltage and primary line voltage. Okay. If it is A2, what is other terminal? A1. A1, A2 means capital vector is there. If it is B2, what is other terminal? B1. And here it is B. If it is C2, what is other terminal? C1. This is nothing but C1, C2 means C is lying between C1 and C2. A1, B1, C1 short with the neutral capital N. Now please take this concept, this fourth point. Always secondary vector should be drawn parallel to primary. Parallel to primary. So I'll draw like this. This is capital A1, capital A2. No, I'll draw simply small a1, small a2. I'll draw without. I don't see this one. I won't see this one. Simply by seeing this, I'm just drawing. After that, I'll check whether the connection is correct or not. I'll write cap small a1, small a2, capital parallel to capital A1, capital A2. This is capital A1, small a1 downwards, upwards capital A2, small a2 upwards. This is small a. Next, small b1, small b2. So I'll draw similarly like this, small b1 and a small b2. This is b. Now small c1, small c2 should be drawn parallel to capital C1, capital C2. Yes, I just drawn like this. This is c1 and this is c2. This is small c. And a1, b1, c1 short with the neutral. Now let me check whether whatever we just drawn that is correct or not. Now you can check here clearly. Here a1, b1, c1 are short with neutral. Yes, it is correct. Your connection terminals are a2, b2, c2. Yes, a2, b2, c2. Correct only. Now, what is the phase sequence of your primary vector? A, B, C is the phase sequence. A, B, C is the phase sequence. A, B, C is the phase sequence here. A, B, C is the phase sequence here. Now, what about secondary side phase sequence? Here, yeah, small a, small b, small c. A, B, C is the phase sequence here. Whenever phase sequence is same, then you can start comparing a secondary line voltage with the primary line voltage. Is it clear? You may get doubt. So which one is secondary line voltage? Let me do one thing. A2 and A1 means that is phase voltage. A2 and A1 or A2 are neutral is same only, no? Because A1, B1, C1 are short with neutral. So line voltage means between this phase and this phase. Example A2 and B2. A2, B2 nothing but line voltage. Now tell me here A2, B2 means I'll take A2, B2 you can take, or B2, C2 you can take, or A2, C2 you can take, your wish. I am taking here A2, B2. A2, B2 means this is A2 terminal and this is B2 terminal. A2, B2. Now, since I have taken A2, B2 here, please here also primary side also please take capital A to capital B2. This is capital A2. This is capital B2. This is A2, B2. Now please try to draw it here, draw this one here. This is this one I can draw like this. Okay, A2, B2 here. Here it is A1, A. Here it is B. Now please everybody. Similarly, please draw this one also. This one also. This is small a2, small a, and here it is small b2, small b. Observe guys clearly this A2, I mean line voltage, second line voltage A2, B2 and primary line voltage A2, B2, they are in phase. Clearly it is visible because A2 upwards, B2 downwards. Here also capital A2 upwards, capital B2 downwards. That means those two are in phase with each other. In phase with each other. So I can write here. So I can write here. What I can write, ma? Secondary line voltage. Secondary line voltage. Second line voltage is in phase with primary line voltage. Primary line voltage. Primary line voltage. We are comparing line voltages. We are not thinking about phase voltage because already we know primary, secondary phase voltage and primary phase voltage are in phase with each other. That means always secondary phase voltage and primary phase voltage will be in phase with each other. Here we are telling angle between secondary line voltage and primary line voltage. Is it clear? So this second line voltage is in phase with primary line voltage. Next you may get one more doubt. So I mean, if we are going to compare this small a with capital A in a clock, you may get doubt. Which vector I have to compare? Small a with capital A or small b with capital B? Obviously, you have to compare small a with capital A because in 2 o'clock I just made A2. I just kept A2 in a place where 12 is there. Therefore, you have to compare small a and capital A, not small b with capital C. So now it becomes what? What becomes what? This is the thing. Small a and small b. Small a and capital A is like this. Or if you want me to write the in phase clearly, I can draw like this. That is this is 12, this is 3, this is 6, this is 9. Primary vector reference what? Minute needle, I told you already. Minute needle means long needle. Secondary vector reference what? Hour needle, small a. Observe clearly. A, small a is in phase with capital A. That means secondary line voltage is in phase with the primary line voltage. Every time there is no need to draw A2, B2, A2, B2, all those things. Simply compare small a and capital A. That gives you angle between secondary line voltage and the primary line voltage. Okay, is it clear? So for this question, this is the answer. Okay. Now tell me similarly answer to this question. Here I'll give connection. Second case primary is just like similar to case 1 primary. That means I'll give input to A2, B2, C2 by providing neutral to A1, B1, C1. This is the neutral point. Instead of taking output from A2, B2, C2, I'll take output from A1, B1, C1 from here by providing neutral to A2, B2, C2. Is it clear? Yes or no? Now, since I did not disturb your primary of your case 1, primary of your case 2, I can draw this one similar like this. I can draw same thing here. Okay. Please try to follow. This is what? Capital A2. A2, B2, C2. A2, B2, A2, B2, C2. If it is A2 terminal, what is other terminal? A1. If it is B2, it becomes B1. If it is C2, C1. A1, B1, C1 start with capital N. From A1 to A2, capital A is there. From B1 to B2, capital B is there. C1 to C2, capital C is there. What is the phase sequence here? ABC is the phase sequence. Here also ABC is the phase sequence. ABC is the phase sequence. Now I won't see your secondary. Simply I'll draw. After that we'll check whether it is correct or not. Okay. First of all, without seeing, I'll simply draw small a1, small a2, parallel to capital A1, capital A2. I'll draw like this. Small a1, small a2, parallel to capital A1, capital A2. B1, B2. I will draw parallel to capital B1, capital B2. B1, B2. This is what I can say B. C1, C2, I will draw parallel to capital C1, C2. C1, C2, parallel to capital C1, C2 is C. A1, B1, C1, I will start with what here? Neutral. But check, it is correct or not. It is not correct, it is wrong. Why? Simple. Here we are taking output from A1, B1, C1, not from A2, B2, C2. But here we just showed A2, B2, C2 outside. Means what? It means that you are taking output from A2, B2, C2 just like your case 1, which is wrong. Because you are not taking output from A2, B2, C2. You are taking output from A1, B1, C1. So what you have to do? Now from this wrong one, you have to draw correct one. How? Take any one reference. I'll take any one example. A1, A2 I'll take here. A2, A1. I just drawn this A1, A2 here. Very good. This is small a. Now observe clearly here. A2, B2, C2 start with neutral. That means to this A2, B2 should be connected. So tell me where is B2? This is B1, this is B2. This B2 should be connected to this A2. At the same time, this orientation should not change. If it is B1 is upwards, B2 is downwards, it should be like this only. And it should be like this, it should be like the same. B1 should be upwards, B2 should be downwards. At the same time, B2 should be connected to A2. That means this vector I have to draw here. Is it clear? This vector I have to draw here. So simply without changing orientation, I just kept this vector here. If it is B1, it is B2, this is B. Is it clear? Similarly, C2 should be started with B2. Here it is a C1, here it is a C2. Here it is C2. This downwards is C2. Downwards is what I can say, C2. This C1, C2 I should take here, I should take like this, and I should keep like this. Then only C2 will come and connect with the A2 and B2. Therefore, this is what I can say, C1 and C2 is small c. This A2, B2, C2 start with what neutral N. Now you can check. Yes, A2, B2 start with neutral. A2, B2, C2 start with neutral. And A1, B1, C1 are constants. Yes, constants. This is correct. This is wrong. Since you are beginners, please first try to draw this wrong one. From this, try to draw correct one. So after having some practice, you can draw directly this one without drawing this one. You just practice from your side. But now, just draw wrong. From this, try to draw right one. Now tell me guys, once again, what you have to compare here? You have to compare secondary line voltage with primary line voltage. What is secondary line voltage? You can take A1, B1. What is there? You can take A1, B1 can be taken as line voltage. Don't say A1, A2. A1, A2 or A1 neutral is same. That becomes phase voltage. Line voltage means what? Between A1 and B1. So A1 is the downwards. B1 is here. And primary line voltage. You have taken A1, B1. So you should take here also A2, B2. A2 is here. A2 is this one. And B2 is this one. Just compare these two colors. So we'll be having some clarity. So first of all, I'll draw A2 and B2. This is capital A. This is capital B. Now please, I'll compare what? I'll write here small b. You see? Yeah. See, I'm just writing small a. I'm just writing this portion. Okay, this portion. That means A1, B1 writing. So that means, let me use different color for this. So understand. This portion I'm just drawing here. Small a, small a1. And this portion, whatever is there, this portion, I can draw like this. Is it clear? You can draw like this. This is what B1 and B. It is actually small a, capital A, small a. And here it is a capital B. It is small b. Is it clear? I just drawn this one. Simple, I just drawn this. This A2, B2, I just drawn it. A2, B2. Capital A, capital B. Here, A1, B1. This is what A1, small a. That's what I can say. I just draw A1, small a. And this is what I can say B1, small b. Now you just compare, guys. This A2, B2 vector and A1, B1 vector, clearly it is visible. There is no doubt that there is no need to confuse. See, between this A2, B2 and A1, B1, they are clearly out of phase. They are clearly out of phase. They are clearly out of phase. You can check clearly. See, A is here, small a is here. Capital B here, small b here. They are clearly out of phase. That means what is the angle? I can write here. Therefore, I can write here. Secondary line voltage is out of phase with the primary line voltage. Is it clear? Now we should know. No, so I'm just going to this one. There is no need to draw. You guys, please, there is no need to draw this portion. For making you understand, that I'm just going to compare A to B2, means I'm just compare secondary, I'm just compare here A1, B1, nothing but line voltage secondary, I'm just comparing with the primary line voltage. For justifying the statement only, I just drawn this one, otherwise not necessary. Please don't draw all those things. This is about primary line voltage A to B2, second line voltage A1, B1, okay, A1, B1. I'm just comparing the line voltage of your secondary, line voltage of primary. For justifying the statement only, I just drawn all those things. Otherwise, you just simply compare small a with the capital A, you'll get the clock. Okay. So now tell me here. Now here, if you observe clearly, if the capital A is at 12 o'clock, small a is also 12 o'clock. In case one, small a is at 12 o'clock, capital A is 12 o'clock, small a is also 12 o'clock. That means what is this connection name? Primary star, capital Y, secondary star, small y, y 12 o'clock, or I can say y 0 o'clock, y 0 clock. Like this, I'm asking angle, I'm asking in with respect to clock, tell me what is the time here. Means you have to compare which vectors? Small a with capital A, not with a small b with capital B. Why? What is the reason? Here 12 o'clock is reference for us. I have taken here A2 reference. I just kept A2 or 12 o'clock place. So please compare small a with the capital A, not with small b with the capital B. So now your answer simply becomes like this. See, just take this, okay, take this and superimpose here. Capital A upwards, small a downwards. You know, this is 12 o'clock, 3, 6, 9. Capital A reference nothing but 12 o'clock, which reference minute needle, capital A. Small a hour needle, which is at 6 o'clock. 6 o'clock. So what is the connection name? Primary star, capital Y. Secondary star, small y, y 6 o'clock. And second line voltage is out of phase with the primary line voltage. In star we got two connections. Number one, y 12 or y 0 o'clock, where second line voltage is in phase with the primary line voltage, and second connection y 6 o'clock, where secondary line voltage is out of phase with the primary line voltage. Okay, this note on this.